Hello everyone, welcome to my channel Any Too Many Networks. So today I came with another topic that talks about how do we select DR BDR in OSPF network. So before I talk about DR BDR election in OSPF network, I'll talk about a few details about OSPF. So OSPF is a dynamic routing protocol used basically in intra autonomous systems. Like, it will be used in some companies, a lot of vendors uses, because it's an open standard protocol. So you can use that protocol for basically dynamic routing. So like, you don't have to use static routing for every. You don't have to go to every router and then say that, okay, if you want to send one packet from one location to another location, you don't have to say that router that, okay, if you want to direct this packet to particular location, this is the route. You don't have to tell. If you just configure OSPF protocol in the routers will take care of your packet to send it to the actual destination that you put over there. So the OSPF protocol will take care of it. You don't have to worry about it. So that is the main importance of this dynamic routing protocols. So one of the dynamic routing protocols that here we are talking about is OSPF. So I'm not going to go into more details about OSPF protocol. I can make another video about that. But today we will talk more about DR BDR election happens in OSPF network, and why do we need DR BDR election. All those details we will talk, because in interviews, if you see, like, anyone can ask, like, what is OSPF, and what is the use of OSPF. Like, not most of the interviewers are not talking about, like, what is OSPF, what is the protocol number for OSPF, and how does OSPF neighbors happen, and then how do you have this adjacent how do you select the routes, and then how do you put those routes in the routing table. Mostly no one is asking like that. Mostly what they would ask is, like, what are the states in OSPF, and what are the types of LSAs, and how does DRBDR election, and why do we need areas in OSPF. These kind of questions they would ask in interviews. So one of the topic among that I have choose today to talk about DRBDR election. So yeah, so let's go ahead and talk about DRBDR election. So for that, have taken a small topology, like, where I have four routers connected to a switch, and I have configured 192.168.1.0 network here for all that, since they are all in a single LAN. Because if you want to see DRBDR election in in real, like, if you want to see, like, really, then you should take, like, because what happens is, if you connect just two routers, you will see one DR and one BDR, and you will not see DR others. But if you take, like, four routers here, you can have one DR and one BDR, and the rest of the routers can be DR others. So there is some terminology here. DR means designated router, which is your, like, main I'll tell you what is the use of DR and what is the use of BDR too. So BDR means it's a backup designated router, and then remaining routers, whoever the routers are in the network, they will be called as DR others. And so what happens is, like, why do we basically need this need this terminology DR BDR? Why can't we just put those routers here and then let them communicate? Actually, what happens is, in OSPF, you don't have any count in having the number of routers in the network. You can have multiple number of routers in the network. Like, it's like you can keep multiple, like, millions of routers. There is no particular number that you can restrict to keep those routers, and to you can actually configure, like, OSPF in those routers. You don't have that particular number. But if you compare this OSPF protocol with EAGRP has particular limit that you can only have those many routers you have to use in that network. But OSPF is not like that. That's why we have a concept of area in this OSPF. But here, why do we use DRBDR? Whenever there is some change in the network, for example, like, if there is a LAN connected on this router on this side, so there is some changes in this network, and if this router wants to update to the other routers, what happens is, in OSPF, it sends the link state. It advertises, basically every router advertises whatever the information that it has learned, it will update to each and every router in the network. So here we only have 4 routers, but usually in real-time production scenarios, what happens is there will be a lot of routers in their companies. So whenever there is an update, it sends to everybody whoever connected in the OSPF network. So in that case, what happens, like each and every router will have to put that entry into the router, and for that and then once it learns, it's gonna send it to the other router. So it's like once it learns some route, it's gonna be like sending to each and every router in that particular OSPF network. So if there is like a lot of routing information coming ahead, coming, and then if they are actually sharing between all those routers here, and if you have like more routers, like maybe 100 or 200 routers, calculating and keeping those, it basically the router's CPU is working here, and then the memory utilization is going high, and also calculating power. If routers does not have a lot of capacity, then the time taking for calculating all that and then putting and installing it in the routing table will take a lot of time. So for that reason, you don't want, whenever you receive a routing information packet here on this router, you don't want that routers to send it to everybody in the network, because it's a time complexity. The convergence time is taking a lot of, it's taking a lot of time. So you don't want that. So for that reason, if you have a DR BDR election among these routers, then you don't have to worry. For example, like if any router receives some routing information, it doesn't need to send to everybody here. It If this router sends to only DR is your designated router, which will act whenever any router in the OSPF network receives some routing information update, it sends only to the DR. So DR will take care. Okay, so the routers will not like send whenever there is an information update coming from DR. These routers will not send it to other routers. But usually if you don't have DR BDR election, what happens is whenever a routing information update comes to the router, it sends to the neighbors, because it's like, hey, I have learned some route from my neighbor. Here is the route. And whenever the other router receives that update, that router also says, hey, I have learned some routing information from my neighbor, so here is the. So you don't want that. If it goes like that, there will be a lot of time complexity, and you don't want that. For that reason, if you put DR and BDR election in the network, then you just whenever you receive an update, you just send it to DR. There will be only one unicast packet, that's it, and DR will take care the rest. So DR will update other routers in the OSPF network, says that, hey, I have received some routing information, so this is the information that I got, please update your routing tables or OSPF tables. Just update your OSPF tables, that's it. For that reason, you need DR BDR here. And if DR for some other reason, if DR goes down, what happens is they both exchange hello messages via multicast address 224.0.0.6. So if DR goes down, BDR becomes inactive, which means the BDR will become a DR, and then other DR others will participate into election, and they fight to get into BDR spot, and then whoever goes down, whoever being in designated router state, that will go into DR other state, and the BDR will become DR, and then other routers, one of the routers will become BDR. So this router will act as, whenever it receives a packet from any router, it sends to everybody. So you don't have other routers to send, to advertise those packets. So for that reason, we use DRBDR. In this way, we are actually reducing the link state advertisements, LSAs. So to reduce those LSA flooding, for that reason, we need this DRBDR election. So I'll just show you how there are some commands to see how we can actually see like DR, I mean neighbors. So let's see. Uh, so I'm on router 1 right now. So if you, there are some commands to see the states of the OSPF neighbors that you have in your network. So if you give show IP OSPF neighbor, you can see here that you will not see their own router ID, like neighbor ID, which is 1.1. This is the real router ID of this particular router. So you will not see that in your router. You will see your neighbors here. So 192.168.1.2 is your neighbor, which is in BDR state here, and then remaining two routers are in DR other state. So this is the dead time interval, and this is that particular IP address of that particular interface. Okay, so and if you go to the other router, like for example, let's go to this R2, and if you give show IP OSPF neighbor, you will see the DR here, which is 1.1 in our case. This is full DR. I mean, there are some rules to select which one should be DR and which one should be BDR. It goes with basically, if you configure a router ID, the highest router ID would become the highest router ID for that particular router will become a DR, and then the rest of the router IDs will become BDR, and then DR others, so on. But if you don't have a router ID, since I haven't configured router ID here, since I have configured first OSPF protocol on this particular router, and it has 192.168.1.1, that's why it choose this one as my DR, and then this one as my BDR, because I have configured OSPF on this router second, and then rest of the routers I have configured later. That's why these two guys have become DR and BDR. Usually it should be 192.168.1.4. This has to become DR, because if you don't configure router ID and if you don't have configure loopback interfaces, then the next preference, the next rule it will check is the physical IPs interface. The physical highest IP interface should be there. Like for example, for this interface, I have configured 192.168.1.4. This is the highest physical IP interface. So this has to become a DR. But here, since I have configured OSPF protocol on these two routers on in the first hand, that's why these guys have become DRs and DR and BDR. So if I want to make this router as a DR, there are two cases. You can go here and clear the IP, OSPF process, or you can do change the priority. There is one more thing that if you want to change explicitly, like if you want to make one particular router as a DR, then you can go ahead on this router and give some command called IP OSPF priority, and if you give some 100 or something, there is a range from 0 to 255. You can give the range in order to change the priority in order to make that particular router as DR. So let me show you that how can you, by default priority will be like 1, I guess. So if you go here and if you want to change the priority of that particular interface, you have to go on to the interface. I'm going on the interface, and if you give IP OSPF priority, if you give the question mark, it's going to give you some range 0 to 255. So if you give like 200, now let's see, I've changed, so IP OSPF neighbor 1.2, 1.3, 1.1. We are seeing 1.1 as still DR. So what happens is we have to clear the IPOSPF process. If you give this thing, you have to be on .OSPF one, I guess. Clear IPOSPF one. No. Maybe I think I have to go on to the interface, I guess. So let's see. Clear IP OSPF. No. I think remembering this commands is like a little bit difficult. Okay, it's giving me hard time here. Let's go on to this router command and see if we can network neighbor area. No. Let's do one thing. Let's go to router OSPF 1 and let's configure router ID and see if it gives us what are the commands to actually clear the IP OSPF process. Let's do 4.4. So it's giving, yeah, clear IP OSPF process command for this to take effect. Yes, clear IP OSPF process. It's not happening. Oh, okay, got it. Here we have to give. So we don't have to give. See, reset all OSPF process. So if you give yes, that's it. It's clearing. So let's see, guys. Like now we have cleared the whole IP OSPF process, and now we will see like uh, whether, since we have changed the priority for this particular router, and we can actually see now, since, yeah, yeah, see 1.1 earlier it was DR, it is in DR state. Now it has changed to DR other. Now let's go on to the other router and see show IP OSP of neighbor. Here you can see that 1.4 will become DR. See 1.4, this is 4.4. I've changed the router ID, so you can see 200. The priority is 1 earlier. Now I have changed the priority is 200, and also I have changed the router ID. Since this one I've changed the router ID, so that's why it has become DR. And then the other one has become BDR, DR other. So you can't, because it's preemptive state. So every time if you do some change here, you have to clear the IP OSPF process. Otherwise, the changes would not get into the place. So I think that's how you do select DR BDR election. I mean, like I know I haven't talked about where, in what state, how this DR BDR election happens, but basically like a few things you have to remember is, in order to become a DR or BDR, you need to have some rules. The first rule would be the highest router ID. Whatever the router will have, the highest router ID will become DR, and then the next router ID will become BDR. If you don't configure router ID in OSPF, then if you have configured loopback IPs, then it's gonna select the highest loopback IP. So highest loopback IP, whatever the router has highest loopback IP, it will become a DR. If you don't configure both of them, router ID and loopback IP, then it will select the physical IPs. Physical IP matlab, if you are configuring like 192, like whatever the IP that you configure on the physical interface, the highest IP of the physical interface would become as a DR. So these are the rules that you have to follow, and also you have a priority, OSPF priority. So for example, if this router has 200, by default all the routers will have priority as 1. So that's why you have to, like, they'll select based on these three rules that I've said earlier. But if you change the priority for a particular router, then it will uh, like it will go based on the priority. Highest priority will become the DR. So if you don't want any of these routers to participate in DR BDR election, there is one thing you can have: a point-to-point network, and there is another one that you can, if you set the priority as 0, then all these routers will go into DR other state and they won't participate in DR BDR election. I can show you that. So if you go here and if you go to this config and interface gig interface gigabit 0/0, and if you uh, go change this priority, okay, R1 is already in DR other state. So what I will do is, this is anyways is in DR state, right? We just change this. So here I will do is, I'll make the priority as 0. Earlier I have changed it to 200. Now I'll do it as 0. So let's see how it works. So uh, so again, interface, you have to go into interface command, ethernet 0. So if you give OSPF priority 0, So now this router will not form into like not participate in DR BDR election. It becomes like DR other. So let's see that. Show IP OSPF neighbor. Let's see some. So if you go on this router and if you see, show IP OSPF neighbor, I've changed the priority for 4. See 4.4. Earlier it was 200 and then it was in DR state. Now if you see 1.2 has become DR. Earlier this one has BDR state. Now it has become DR, and then the next router whichever has the uh, like wherever I have configured OSPF protocol has become BDR. So this is 4.4.4. It has become, it has gone to DR other state. So now you can't, you have to change the priority in order to make this router again to participate in DR BDR election. I think I have covered all the points for coming to DR BDR election. The only thing is you might say that when this DR BDR election happens and in what state. So it happens in two-way state. I will talk about the states in maybe in the next video, where they send their router IDs or maybe whatever the neighbor IDs that they have. They send the information through hello messages, and then whoever has the highest, whatever the rules that I have said, based on those rules they form DR BDR. So one thing you have to remember from this video is that why do we need DR BDRs in OSPF? The main reason is to avoid the LSA flooding. So every router will learn something routing information about the other router. So it should not send to everybody. So we have to restrict that. If we don't restrict that, there will be a lot of there will be time complexity for calculating the whatever the routes that the router learned. It has to put it to the routing table. There will be a calculation. So the time complexity is there, and also your resources. There is not only one route. There will be lot of routes that will be your router will be learning from the other routers. So there will be a high resources of your CPU, and there will be a memory. So all that you don't want to have it. For that reason, to avoid LSA flooding, you need DRBDR election. I think that's all I have. Thank you guys. Have a good day.